Tensile strength is the strength in tension, that is, a pulling force. To test tensile strength, you put a sample into a tensometer and pull until it breaks. This sample of mild steel broke at about 8 kilonewtons. The cast iron breaks at about 5 kilonewtons. So although cast iron is harder, it is weaker in tension. On a larger tensometer, it is possible to see how mild steel behaves under tension. At first, it stretches elastically. That is, it will return to its original shape when the load is removed. Then it passes its elastic limit at the yield point. Any stretching beyond here is permanent. The sample necks and then ruptures. Comparing it to an original bar, you can see how much it has stretched. Toughness is a measure of how much work it takes to break a steel. If it is strong and also bends a lot before breaking, then it takes a lot of work to break it. This machine allows us to compare the impact strength or toughness of various metals. Mild steel distorted a little and absorbed the energy of the weighted pendulum. It is very tough. Now cast iron. It snaps easily and there is even energy left over. So although it is hard, it is not tough. It can't absorb energy because it doesn't stretch before it breaks. Brass is similar to mild steel. Malleability is the ability of steel to be distorted by compression or squeezing. How easy it is to be rolled or hammered out into a thin sheet. The malleability of steel varies with its carbon content. It is very malleable when it is red hot. When steel sheet is being pressed into shape, it needs to be malleable, and it needs to be ductile as well. Ductility is the ability to stretch. The melting and softening point of metals varies a lot. A drill point may get hot, so it must have a high melting and softening point.